Hi there, knife people, hello lady and gentlemen. Welcome back to my lab of knives. Tonight I'm going to throw everything at you. My microscope, my hardness tester, and a lot of discussion about a knife as a system. Recently I published two other videos that involve these four knives. Spydie Native 5 Salt series, brand new series from Benchmade Water. This is Adira, full-size knife. MKM Yipper, and as a sort of baseline sample, this Benchmade bug out. I hope you remember how it all turned out, but if you don't, here's the link, and here's why I did it. In the last couple of years, most knife making companies were in this pursuit of attracting more and more customers by promoting better and better blade steels. We ended up with MagnaCut, which is an absolutely fantastic steel. But only few manufacturers, only those who take these things seriously, ended up building a knife around the blade that is as corrosion resistant as that blade steel deserves. Tonight we're taking a deep dive into what happens when they do and when they don't. Before we start looking at the knives that sustain some degree of damage from being subjected to the accelerated corrosion test in my previous video, and funny how they're all blue, I just realized. Anyway, let's look at the yellow knife, Spydie Native 5 Salt. You will see under the microscope that the blade actually had some scratches, which could actually facilitate propagation of rust. But nothing of that nature occurred, even though the tip of the knife, right there, was accumulating condensate from salt fog. These longitudinal scratches are from the tree trunk that spent God knows how much time in the water and sand and silt, so it was impregnated with the sand particles, and that's what did the scratches, because silica sand is harder than steel. It's interesting, I need to point out, because you know I'm a sharp edge junkie, even though I beat the living lights out of it, 25 very hard stabs. I'll provide a link to that video. The edge remains like new. The actual apex of the knife is in excellent condition. So let's take a look at, first of all, I had this baseline sample. My poor old bug out. And it's spent now almost 48 hours oiled up with the rust penetrating oil. Here you go. That's what it looks like. Let's see under the microscope what it is. Looks like the oil did a good job penetrating and lifting the rust off the surface. It gelatinizes it, or turns it into some sort of filmy substance. There might be some penetrating corrosion where they laser etched the logo, probably because heat produced by laser etching changes the composition on the surface of the metal. Doesn't look so good. Let's take a look at the thumb studs next. So the area around the thumb studs looks like it's affected by corrosion as well. So that's the baseline knife. And the next worst was Yipper. The tip sustained some corrosion. What we're going to try to establish today is whether it's penetrating corrosion or surface deposit. So where they laser etched the word MagnaCut, the corrosion was the worst. So you can see where water got into the laser pattern. You have corrosion on this side as well. And that's what's coming out of the inside of the handle. Inside that pivot and lock mechanism is where most of the dissimilar metals are. So full-size Benchmade Water Adira. It has this much corrosion at the tip, and then near the edge right here, and there's good news, not much around, or nothing really around. That's just dirt what you see there, nothing around the thumb studs. And then let's take a look. All right, clearly something was happening inside or on the steel. This is a steel crossbar. You can see the spring there. Now let's look. I said a lot about the clip in the previous video, so I'll have to adjust the focus here again. You can see a little bit of a rust here, and this is a tumbled finish, so stone washed finish, and you can see that corrosion mainly originates where the metal is exposed. Time to take a look inside these knives. All right, so let's start with a world-class standard for corrosion-resistant knives. I'm now convinced that's what that is. As you can see, there's absolutely nothing on the inside that corroded. Not the mainspring, not the actuation bar, even the embedded nuts, they're not corroded at all. Yeah, as you can see, even when where the screws are in contact with the embedded metal there. And to determine why it went so right, I am tempted to remove the blade here and give it a hardness test. First things first, I have to verify that the calibration from the last use is still good. It's supposed to read 58.7 Rockwell hardness, C-scale. That's what this metal block is calibrated to. As you can see, I ended up with 58.5, which is 0.2 of a point below, or more conservative, than the actual block supposed to be. Microfiber works best. I'd like to take a moment and give a shout out to Dan Matheny, Mr. Bowser, Jesse Herbert, Ihor Chernetsky, and John Gibson for purchasing the super things. Guys, that really helps a lot, both financially and mentally, to keep the channel going. And the same goes to all my viewers who took the time in their busy day not only to watch my video, but to ask me questions, to leave comments, share the link with their friends. All that really helps the channel going and promotes it to more people so we can get the word of truth out to them. So this blade is at 61.5, 61.7 if we add back the 0.2 we lost in calibration, right? So, you know, that's why a lot of companies do it in this range. They try to be stainless. I could spend 20 minutes connecting this result to the tables provided in the MagnaCut article by Dr. Laren Thomas. It's a little bit, you know, of an investigative effort, because in the article he specifies certain austenitizing temperatures for different level of corrosion resistance. He left me wondering what kind of normalizing temperatures and durations one should use. So if we look at the austenitizing temperature that is best for corrosion resistance, it looks like Spyderco chose 2000 to 2050 Fahrenheit for the austenitizing temperature, which gives us 61.5. While the knife is disassembled, I have to find the answer to the question that I posted in the previous video. Is the log bar in a Spyderco Native 5 Salt series made out of MagnaCut? And so I'm going to test it as well, which is challenging because it's a very narrow piece of steel. 58.5 is not bad for a subcomponent like this. Let's try it again. 59.7. I couldn't tell without the spectrometer, but MagnaCut is plausible. All right, let's open the Yipper and hear what it looks like inside. Clearly, something is going on at the crossbar lock. Okay, now the blade. Oh, yeah. Bearing's cage is brass, not bronze. Please take a look at this table, which will show that combining brass and stainless steel yields a pretty high risk of galvanic corrosion, while using bronze reduces this risk. Look on the... Oh my. Oh my. Oh no. Wow. Wow. That's all I can say. Now I have to take it completely apart. The little spacers are okay, the back spacers. I'll just, we need to remove that. Yeah. Even on this side, there's something going on. Something is going on here, right there. Oh man, right by the spring. Yeah, and the spring corroded here. I also want to subject it to hardness test. There are a lot of speculations about how hard or soft Italians make their knives. This is made by MKM of Italy, MagnaCut consortium of knife makers. So we're gonna turn this thing on. By now you've seen me do this several times, so let me speed it up a little bit. The dropping sound you heard is the cartridge inside there with a little tungsten ball drops onto the steel, and then the computer measures the velocity with which it struck, and then velocity with which it strikes the second time. That's how that works, and then calculates the hardness based on that. And after 5 strikes, I get an average 58, as everybody was saying. 4 points below the recommended hardness. The Omega spring is corroded, and what you see on the screen is not as bad as if I left it unattended without applying penetrating oil to it. Within days, the spring would start to pit in this area and eventually crack. Taking a look at the crossbar, clearly there was corrosion forming between it and the liner. That's where the liner touches the crossbar. So clearly the liner is not nearly as corrosion resistant as the MagnaCut on the blade. And that is what I'm talking about precisely. When you're designing a knife, you have to look at it as a system, a sum of the components. Let's recap. Clearly the liner is made out of less stainless steel than the MagnaCut. And so the dissimilarity between the two steels, or possibly the presence of brass in the bearings, caused them to form a galvanic couple when exposed to salt water, electrolyte. Once that happened, the iron in the steel started oxidizing, turning into rust. As you can see, there's permanent damage to the steel, represented here as discoloration. This is similar on a chemical level to oxidation when the acid is dropped on a metal. So basically, by applying the oil, I halted the reaction, and now I'm able to salvage the liner. So when the knife salesmen are giving you an opinion solely based on promotional information given to them by the knife manufacturer,
I really appreciate the extreme stain resistance. Just being able to rinse off a knife and kind of put it away a little carelessly, it's nice peace of mind knowing that you're not going to come back to a rusty blade.
Yeah.
You know, Seth is actually not wrong. You would not come back to a rusty blade. You would come back to the entirely rusted knife, including the Omega springs, which is really a crossbar lock killer. Here's the real culprit. This is a steel ball bearing with a brass cage, And what do we know about brass? It is mostly copper. It's really good at conducting electricity, so when it is submerged in electrolyte, it provides a steady flow of free electrons which create electroetching effect on the steel, especially if that steel is not specifically designed for corrosion resistance. When you mix this many metals together and then get your knife wet, even if it's just rainwater, fresh water, it will start corroding due to galvanic coupling. Every steel has iron in its composition, and once it turns into rust or iron oxide, that is it. The process is not reversible. You can arrest the process by applying oil or other passivating compound to the blade, but what already turned into rust will never come back. So even if you don't live next to the ocean or don't take your knife to the seashore, you still have risk of corrosion if you leave your knife wet or even just humid somewhere where there is no ventilation. Your body sweat is corrosive as well, far more so than fresh water because it has both salinity and acidity. Rinsing, drying, and applying a light coat of oil. That's all you can do to prevent rust. The time has come to look at Benchmade Water Adira. You too fell victim to design by committee approach instead of sound engineering. You can watch a bug-out disassembly video to take this one apart. They're nearly identical in their design. An oversized bug-out, that's all this is. Which means it also runs on bronze washers. While also a copper-based alloy, bronze is less galvanically reactive than brass due to high content of phosphorus. Better, but not corrosion-free. In a whole knife universe, the only corrosion-free washers are made of nylon. Looks like it in the spring, the tip of the spring. Okay, so let me pull that out. Yeah, the spring is toast. We need to look under a microscope. Nothing could have gotten onto this from the inside of the knife because of how it's orientated. So this is honest to God oxidation or rust. The liners, this is like new on both sides. This one had a little bit of a deposit here. Here the bronze washer. You can see it also has deposits here. This is good news and bad news. So looks like this is also surface corrosion, which probably means there'll be some on the springs. This one was definitely starting to rust. You can see the brown, reddish brown spots on the curve there, especially on this side. Flip it back. I believe at this point it'd be fair to say that these springs can easily corrode. Here's the one that was less exposed, and you can see the difference in the finish. From all the evidence I've seen on internet, the omega springs break in the middle of the larger loop. So you can see the difference. The one that was more exposed has darker color. Time for the hardness test. I already tested it in the previous video, but I wanted to retest with a 5-strike average instead of 3, just to make sure I gave you accurate results, or as accurate as I could possibly do using this equipment. And today the gods of testing are with me because, as you can see, the deviation is small. So now I can inform you with certainty that the blade is just under 62 HRC. Now I want to test the liners because I suspect it's not nearly as high a grade of steel as the blade. So it might be stainless, but it's very basic, inexpensive steel, which means the knife was designed for manufacturability and cost savings and not specifically for corrosion resistance. So when we say this knife is reasonably priced, the reality is it's just less expensive than other new Benchmades that have been recently coming out. And that's what this video was all about. how would a knife that you spend good money on perform as a system, as a whole item, and not individual component like a blade. Clearly, we can put this to bed. Spydie Salt series, absolutely spotless, performed extremely well. Let me change the camera angle and talk about these other knives. I spent almost 2 hours cleaning these knives last night. I was able to clean them to almost like new condition because I applied this penetrating oil pretty early on. So I didn't let the corrosion penetrate the blade material. With the exception of the Yipper, there's no damage internally or externally to the knives. The Yipper has liner, one of the liners that corroded, but when I removed the oxide layer, it's just discoloration underneath. And the knife functions quite well. I still like this knife. Let's talk about these two. Actually, Adira performed really well. Comparing to, for example, bug out. Definitely the rate at which it was corroding was much slower than on the S30V. But reality of it is, as I mentioned in the video, I think this is just a supersized bug out. And the reason I think that is because internally they're extremely similar. They're very, very similar. There's almost no differences in how this is designed. Same screw arrangement, basically the same knife scaled up, and the shapes are different, obviously. So if you already own the bug out, you can skip the mini Adira. As you can see, they're near identical in blade length, blade actual shape. Ergonomically, they are the same. If you need a larger knife that has lightweight construction, then this is your knife. But don't buy it because you heard a salesman tell you in a YouTube video that somehow MagnaCut is a magic, completely corrosion resistant steel. It's largely dependent on what's inside the knife, as you can see here. Another important thing I wanted to point out, if you are a proud owner of a bug out or a Griptilian, you will not gain a better grippiness out of this knife. This knife is just as grippy or just as slick as the Benchmade other Grivery and FRN knives. So plastic is a plastic. There's plenty of texture on this knife. There's plenty of texture on that knife. Texture is not a differentiator here. So size and price are the two differentiators. And that was the end of this story, but not the end of the video. Because on my table I have Benchmade Hunt series called Steep Country in S30V, Spydie Salt series ARC in H1, Pivot in HCR 13 MOV, that I think is a $25 knife, and brand new, freshly out of the wild below, Benchmade Intersect, which is the smallest of all knives in the water series so far. I also have a leftover 2 liters of 1% salt solution that I am eager to unleash on these knives. What do all these knives have in common? Mainly, it's a simple construction, chunk of steel over molded handle. So, it's not going to be about galvanic corrosion, bimetallic composition. It's going to be all about the blade steel. But if you choose to, I can throw the sheaths and all the trinkets that come with these knives into the mix. Let me know in the comments, how would you like me to test this?